Hi, this is Graham Bell. I'm speaking with Lisa Piper, Senior Technical Marketing Manager at Real Intent. How are you?
I'm fine, thank you.
You've been in town this week, and we've been talking about the new Ascent XV release that's coming out on Tuesday, March 25th. What's going on with SoC design and verification these days that verification of X's is such an issue now, maybe more so than what we saw in the past?
X's have always been an issue because all flops will power up to an X value. X's are more of an issue these days because of low power, and you can have various blocks in a design at various stages of power. There can be a lot more X's transitioning between the blocks and at different times other than just the initial power on. So there's more X's in the design, so there's more probability that these X's can cause problems overall.
Why are X's a problem in design?
X's are a problem because they are not simulated accurately. Most simulators in their normal efficient mode of operation will simulate X's inaccurately. So for example, if you had an if and a condition, if the condition is an X value, it gets treated as though it were a 0 value. And that can cause the simulation results to be inaccurate, which can, of course, mask a bug in your design.
So we have a new release of Ascent XV come out. What are some of the key features of this new release?
Ascent XV does two primary things. It does an analysis of all the X's in your designs that can cause problems, and it will trace the propagation of those X's through your design to help you know where those X's can propagate to X-sensitive constructs. So we have enhanced the first part of determining where the X's are in your design to provide more debug information for the user. Not only do we report the uninitialized flops, but we will show you how flops become initialized. So we'll show you all the flops that become reset at time 0, presumably from asynchronous resets, as well as we will tell you the flops that get reset with the first clock, either from a synchronous reset or through propagation, and we'll show you how other flops will become initialized over time through propagation, and we'll show you the value that those flops get initialized to. So you can kind of see how your chip is becoming initialized or why it isn't becoming initialized. We will also give you a sense for those flops that are not yet initialized. We will tell you how many X-sensitive constructs those flops might propagate to. And this is important because it tells you, it gives you some kind of priority ordering so that you can know which X's you need to eliminate. The other thing that the tool does, which as was done in previous releases, we have improved the performance on this, is for those flops that are not yet reset, we will suggest a small subset of those flops to add a reset to that in the end will result in the full reset of your design.
What are the advantages of just having a minimal subset that you're sending reset signals to?
If you were to send a reset signal to every flop in your design, you will likely have problems with routing in the end. And of course, there's always an incremental power and area for each hardware reset. So overall, while you want a complete reset to eliminate those X's, you don't want to have to run a reset to every single flop in your design.
Are there any other enhancements to the Ascent XV product that you'd like to mention?
We are trying to provide more debug information. So we will tell you what X-sensitive constructs an X can propagate to. You can eliminate the X source that is propagating, and for that we have added a better schematic display of how the X source can propagate to that construct. And we use Synopsys Verity for showing that.
Are people trying to use their simulators to handle these X simulation difficulties? Can't they just throw a switch on their simulator and that will solve the problem?
There's two big issues with that. The answer is yes. It will tell them if there are issues. However, it has a significant performance impact on their simulator, and if there are issues, it does not help you with debugging the problem.
What about performance and run times? If I have a million gate design, how long would that run?
The x-propagation analysis is very fast. It will typically take a couple hours to get through a million gate design to get through doing a resetability analysis. If you want to do complete formal resetability analysis, then it would probably require an overnight run.
What's the one thing you like about the tool and you think makes it really stand out for designers and you really like?
I like the fact that it will tell you how many x-optimistic constructs a particular X source can propagate to, because that enables you to know, is it important to eliminate this particular X source, or is it going to be innocuous anyway? If it's not going to propagate to any X-sensitive construct, then I can just leave it. That's the part that I like the best about the tool.
Lisa, thanks for speaking with us today.
Thank you.